Okay, we're going to review simplifying radical expressions, simplifying radical numbers, variables, and expressions. First thing, let's talk about the anatomy of a radical. A radical is divided into these four parts. The radical is actually this little check mark thing right here. This is the radical for this expression. The degree tells you to what degree are you rooting or doing the radical. If you do not see a number here, that is implied that it's to the second degree or squared. If you do see a 3, a 4, or in this case a 7, it is to that degree. But if you don't see a degree, it is implied that it's to the second degree, which is squared or square root. This little bar is called a vindiculum. I did not know that. So this is just a grouping symbol to remind you that everything underneath it is going together with the radical. So it's a grouping symbol that reminds people that things underneath it, in this case is called a radicand. What's underneath it is called a radicand. So the vindiculum is a grouping symbol for the radicand. This radicand happens to have two terms. So with that being said, this radicand is underneath the vindiculum. A radical expression is an expression that contains a square root, or a radical. A radicand, the expression underneath the square root, in its most simplest form contains no perfect squares, no other perfect squares factors other than 1. So in order to simplify any type of radical, it needs to have a factor of 1, nothing other than 1. We are going to start by simplifying radicals without variables. These are just basic numbers that we're going to simplify our radical expressions. Okay, now we're going to simplify radicals without variables. When you're simplifying radicals without variables, you want to remember your perfect squares. So just to write the first 5 perfect squares, 1 times 1 is 1, and that's the first perfect square. 2 times 2 is 4, and 4 is the second perfect square. 3 times 3 is 9, and 9 is the third perfect square. 4 times 4 is 16, that is the fourth perfect square. 5 times 5 is 25, and that's the fifth perfect square. With that in mind, you're going to look for the largest perfect square that is divisible by 18 without getting a decimal. Do you know what number that is? That is 9. So the square root of 18 is congruent to 9 times 2. I know what the square root of 9 is. The square root of 9 is 3. So the answer to the square root of 18 is simplified is 3 times the square root of 2. Now let's look at 27, square root of 27. What is the largest perfect square that goes into 27? Did you guess 9? That is correct. Nine times 3 is 27. The square root of 9, again, is 3. So the answer here is 3 times the square root of 3. What perfect square goes into 32? Did you guess 16? The square root of 16 times the square root of 2 will give you 32. The square root of 16 is 4. So your answer is 4 square root of 2. Lastly, what perfect square goes into 75? It's not 50. The square root of 25 times the square root of 3 will give you 75. The square root of 25 is 5. So the answer is 5 square root of 3. Now let's try simplifying radicals without numbers. So with that same thought in mind, you are looking for an exponent of 2. Every set of 2 will get that variable out of the radical. Let me show you what I'm talking about. How many sets of 2's are here for the v? There's only one set of 2's. So that means only one v can come out, and that's done. How many sets of 2's are with c to the 4th? There are 2 sets of 2's for c squared, for c to the 4th. So you'll have c squared that comes out. How many sets of 2's of exponent of 2 does d to the 6th power have? Three. 3 sets will come out. So the answer to this is v c to the 4 is v c to the squared, and d to the 3rd. So let's try this. Are there at least one set of 2 of m to the 2nd power? No, there's not. So m must stay right where it's at. How many sets of 2's, how many pairs are of n to the 2nd power do we have? There's one, so that n can come out. And what about p? There are 4 sets of 2 that can come out. And nothing remained. So n stays inside the radical. What about here? J to the 5th. 2, 2, and 1. So that means there are 2 sets of j's that can come out. One set must stay in. What about k? One, two, three. 3 sets of k's can come out. One of them have to stay in. What about m? One, two, three, 4. M has to stay at. One m has to stay in. So our answer is, let me clean this up a little bit. J squared, k cubed, m to the 4th is all being multiplied by j, k, m. Last one. 2 from 3 is 1. So there's 1 set here and 1 on the inside. Three X's came out. 2 sets of Y came out and 1 Y stayed in. Here's your answer. Okay, we are now going to simplify radicals with numbers and variables. But this time, you're going to do the work, and then you're going to check your answers with me. So when I say pause, go ahead and pause the video, do the work, and then check your answers with me. All right, let's start with the first problem. Go ahead and hit pause, and then you're going to check your answers with me after you finished your working the problem. Hit pause. Okay, you should have answered 8 x squared y times the square root of 6y. How did we get that? 64 and 6 are 64 is the perfect square that goes into 384. Square root of 64 is 8. You keep your square root of 6. That doesn't break down. X to the 4th power simplifies to x squared because 2 sets of x squareds are there. Y to the 3rd power breaks down into y squared times y. So the y squared breaks down or simplifies into y, and this one stays into the square root. So 8x squared and y are here on the outside. Square root of 6, square root of y are on the inside. Now, go ahead and hit pause so you can do number 2. Okay, did you get 36x times the square root of 2? Then you did it right. 6 on the outside comes all the way over here. 72 can be broken into square root of 36 times the square root of 2. The square root of 36 is 6. The square root of 2 doesn't simplify. X squared simplifies into x. So on the outside you have 6 times 6, which is 36 times x. That's how we got our 36x. The square root of 2 stayed on the inside. There's nothing to multiply it with. Okay, go ahead and hit pause and do problem number 3. Hit pause now. Okay, and we're back. Did you get 40a square root of 5? If you did, you've done it correctly. 5 is on the outside of the radical, so it comes all the way over here. 80 can be broken into 16 times 5. Square root of 16 can be simplified into 8. The square root of 5 cannot be simplified. A to the 2nd power can be simplified into a. So on the outside we have 5, 8, and a. 5 times 8 times a. 5 times 8 is 40 times a is 40a. And then of course your square root of 5 comes all the way over. Last problem, last time. Go ahead and hit pause for me. Did you get negative 16k times the square root of 6k? If you did, you are correct. I know it's a little jumbled, but you have your negative 8 times the square root of 4 times the square root of 6, which the square root of 4 will simplify to 2. So it's negative 8 times my 2 times there's 3 k's here, so 2 of them come out. So there's 1k there, so it's negative 8 times 2 times k is negative 16k. And then we have you have 6 square root of 6 and the square root of k together underneath the radical. So there goes your 6k underneath. Great job. Thank you for your time.